This is the start of like jiggle physics. There.
Hey man, it's a slippery slope. Hey everybody, I'm Jay. Today I'm going to be teaching you guys about vertex displacement. So this is a little character that I have running around. And basically at the end of our little session, we're going to make a mesh that just through material code and a bit of blueprinting, it kind of comes to life. Little squash and stretch and all that fun stuff. So that's what we'll be working with. Now, if I hop it over to Photoshop, I'm going to try to break down the steps in like a what are we doing here kind of way, and then try to go through it in the code. So we have our object, right? What we're basically going to be doing is creating a gradient from the bottom to the top of our object, so that like the bottom of the mesh is black, and black is like, think of it as like the 0 value. The top is white, think of that as 1. Anything multiplied by 0 is 0, anything multiplied by 1 is that thing. So what we're going to be doing is we're going to be basically telling it like some vertex instructions and then multiplying those by our gradient here, right? So without the gradient being multiplied, if I told all the verts to move up, our little camera guy would go from here to up here. And I'll hop in the engine and kind of show how that would work. So I'm going to create a new material. I'm going to call it Wiggle Mat. You guys can call it whatever you want. And open that up. For my purposes, I'll be using the matinee cam mesh for all of this. What I'm also going to do is run over and steal the material code from it. And then add those to our material, just so I'll be working with the camera mesh the whole time. So I'm gonna apply the vertex thing to this new material with the camera textures and all that stuff. Okay, so now that we have that set up, let's head back to, let me save this really quick. Okay, so if we hop back into Photoshop, let's start with the idea of moving all the verts up. So yeah, let's kind of start from the ground up. If we want to move all the verts up, how would we do that? So position is a vector 3. So if we hold the 3 key down and then click in our graph, we will create a vector 3 node. So let's feed this into the world position offset input. And from here, let's like add 50 to the B. Just like that, our mesh moves up. If I wanted to, I could put like 500 in the X. And it's way over there now. Same goes for Y. Y'all should get it from here. This is basically telling all the verts to move up 50 units. Okay, so here's what we got. So far, we have the instructions down for this first part, just kind of getting our bearings straight. Now we need to implement this little gradient part of it. This will get weird, and I'm going to try to keep it surface level, just so we don't get lost in the weeds of it. But we're going to get pretty nodey here in a second. I'm going to create a new node called absolute world position, and you'll search this by putting world position. Let's preview this right now. And I'm going to bring back the cube. Just for my purposes, I'll bring back the cube just to see how it looks. And let me disable the vertex movement. Okay, so we get a bunch of weird colors. Where are these weird colors coming from? What does putting position into the base color do? What does all this mean, basically? So think of how every color value has an RGB. Think of how every position has an XYZ. Okay, so what we're seeing, these color values are literally the numbers of where their positions are fed into the RGB value. And so like the world position node is every pixel has a location, and the color you're seeing is the RGB of that location. What we'll need to do is subtract our object position from it. Sorry. So search object position, feed it into the bottom of the subtract node, and plug that in. Nothing's changed visually here, but basically what we've done is we've just made the world coordinates move with the object position. So yeah, all right, I will unplug the subtract node that I just added. I'll do this for demonstration purposes. You guys don't need to follow this, I guess, unless you'd like. Without subtracting the object position, I got these colors here, right? If I move the object around, the object moves, the colors stay where they are. Now, we don't want that. Our mesh is going to move around. We want our 0 to 1 gradient to move with us, whether we jump up and down, whether we move left or right. So subtracting where the object's position is moves it all together. That's the long short of it. Cool. We are one step closer. We are going to divide this output by the node called object bounds. And so when we divide this by the object bounds, it looks just like we smoothed out the values, but what we really did, in a weird way, it's almost like we zoomed in on the gradients that were really there. So if I disconnect this again, and I zoom in really close to this pink and white area here, you can see the gradient. And same thing with the very like dead center of the mesh. And I'm dividing it by the object bounds. So basically what we wind up with, and I'll show you, if I were to mask just the R channel of this, we're looking a bit closer to getting like 0 to 1 sort of ranges. The range we're dealing with right now is -1 to 1, which is close. It's very close. And a way that I like to debug and kind of know actually what values I'm working with is I use the step node a lot. And whatever number I put in here, it kind of just shows me like the line where that value is. So if I put in 0, it's dead in the middle of this. If I put in like 0.9, it's up towards the top. If I put in -0.9, it's down towards the bottom. You know, -0.9 is close to -1. 0.9 is close to 1. I'm like, okay, so that's my range that I'm working with. This is kind of how I like to debug things sometimes. So how do we turn this -1 to 1 into 0 to 1? There is a quick little node called constant bias scale. And if you feed that in, our gradient changes again. So if I pull out this mask node again, and I check out the blue channel, the vertical channel, here we go. Now we have a 0 to 1 range. Cool. So hopping back to our Photoshop file, we have our instruction of move all the verts up, and we now have our gradient that's mapped to our object, right? I'm going to comment this all and call it our gradient, if I can spell. Okay, so like I was saying in the Photoshop file, if I were to just simply multiply these and then feed this into our world position offset input, we are now stretching our model vertically. Let me get my camera model back. And if you want to fiddle around with it, we can add to the X as well. We can add to the Y. We can really kind of go crazy with what we're doing here. Now, here, let me set this up so it looks gooder. If I did -50 in the X here, it looks like my camera's moving to the left, right? What if I want like the top to like, what if I don't want the linear perfect slant? What if I want it to bend a little bit more? How would I do that? Well, I'll tell you. It's what I'm here for. You could add a power node. Add a power node and add a new parameter. I'm calling it bend bias. You could call it whatever. And feed that into the exponent. And set the default value to 2 for now. And just like that, it's a little more curved. It's a little more fun. You could change this value to whatever you want. For like different intensity. Like my final version of this has a lot of variables to like really fine tune the settings that we want. But I like how it looks at 2 for now. We are pretty close. Like we're about halfway done with like the movement part of this. What we'll do next is we'll go to our content browser. We'll make a new blueprint. It'll be an actor class. Call it whatever you want. BP wiggle object for me. And we'll open it up. Let's add a static mesh component. If you want to rename it, go for it. Over here in the details panel, I'm going to set the static mesh to be our camera mesh. And I'm going to change our material to the wiggle mat we've been making. Cool. Alrighty. I'm going to make a slight adjustment and center this object to my blueprint. And you guys should do the same. Okay, let's hop in the event graph. Okay, so where do we start? I need to get access to the material of the mesh. So let's start there. I'm going to drag my mesh out into the graph from the components panel. I'm going to drag out of the node and search create dynamic material. Let's set our source material to our wiggle mat. And then we'll pull out of this and promote it to a variable. And I'm going to call it matref. So with our material reference, what are we trying to access in our code here? What are we trying to do? We are trying to, in the end, right? It's based on like the direction we're moving and the speed we're moving at. So let's keep that in mind. Let's change this vector3. Let's right click it and turn it into a parameter. And let's call this direction. I'm going to hold M and click to put a multiply node down. I'm going to feed direction into the top part of it. And from the bottom, I'm going to hold S and click. Oops. I'm calling this move intensity. This you should probably try to match what I have written. And then plug that into the bottom of the multiply. Now move intensity, let's set that as a default value of 50 for now. If your direction node has any values like set to anything, just put everything back to 0 for now. Okay, back in our blueprint. We are now going to pull from the details panel. We're going to pull our mat reference variable out into our blueprint here. We're going to pull off of it, and then we're going to do set vector parameter value. Right now, what I'm going to demonstrate is how to change the direction parameter in our material, just for now. And I'll do it on begin play. I'm going to, for parameter name, I'm going to change this to direction. And then out of this node here, I'm going to type add timeline. The name can be whatever of this timeline. Okay, from there, I'm going to feed the update into this node here. Now I'm going to jump into the timeline node. I'm going to create a track, add a vector track. Call this one move. What I'm going to do, in case you want to get ahead of me, is I'm just going to make the X, Y, Z just zigzag up and down a lot. So that's what I'm working on right now. And then for this last one, I'm going to set all their values back to 0. I'll hop back to our event graph. I'll pull this move out and I'll feed it into the value node, the value input here. Sorry about that. There's one thing we need to adjust with our timeline node. We need to hop back in it. We need to turn on the looping up at the top bar here, and we need to turn on use/keyframe. Again, this is all for demoing purposes. This does not need to be followed religiously. Okay, so let's see what happens if we go to our viewport and hit the simulation button up here. Oh snap! Have you ever seen like a boombox in sort of like music game where the boombox is like shaking and stuff like that? That's what this is looking like. The thing that I'm teaching you guys here could be used for a ton of different purposes. Like if you were holding a torch in a game and you want the flame to like drag behind, that could be another way to use this. When I first had the idea, I was thinking of like in the case of a level editor, dragging around like trees and buildings and the trees like going, whoa, whoa, stuff like that. So I'm going to stop the simulation. We've got that working. Now, we're dealing with direction. And I'm sure if you've taken any of Varun's coding classes, you know that to get direction, you need to know your location at the last frame. Okay, so we're getting in the weeds of coding just a little bit. Down in the variables, add a new variable. Call it past location. What I'm going to be doing here is on tick, I'm going to be running some code, feeding those variables to the material, and then at the end of it, I'm going to be setting the past location to the now current location. So I'm going to go ahead and do that. So let's create a tick node. Let's pull out our past location. Let's get our mesh component. You could pull from the components tab again if you'd like. And we drag out and we search for get world location. Now, what I'm going to do now is I'm going to copy and paste this vector parameter value from up here, this node from up here, and just get it ready for taking values here in a second. So, I mean, this parameter is named direction. So let's pull out of one of these vector nodes and search for direction. The node is called getUnitDirectionVector. and then we'll feed it into our material node. Now the last thing we got to do is, at the end of this code, we'll need to set the past location to the now current location. So with this code here, let's see how it's acting. Let's see how it's doing. Let's drag our blueprint into the world, and then we'll run it in simulation mode. Because one of the things I'm going to skip with this lesson is setting up the controls so that it moves like a character. You could just run it in simulation mode and then drag it around, and it does the same stuff. Yeah, okay. So when we're dragging this around, we got some things, we got some issues, and that's expected. So what are some of these issues? One, the shadows, they're like doing this weird artifacting thing. So let's go back to our blueprint. Let's click on the mesh component and then turn off the shadows in the details panel. But if you search shadow, you'll turn off the checkbox for cast shadows. That will fix up the weird artifacting thing going on. And something else that was wrong was, you notice that it was tilting in the direction that we were moving, and we wanted to do that the opposite way. So you could either flip these values here in our get unit direction vector node, or you can just pull out the end of it and run the negate node. It's called negate vector, which flips it. Okay, now let's run it again. See how we're looking. Look at that, a little wobbly. Isn't that fun? Make sure, okay, I ran into this when I was testing this. Make sure your rotation and location snapping is off in the corner. Make sure it's not snapping to a grid or like a rotation angle up here in where my mouse is at. Now you may be noticing it still looks a little jittery. And the reason why that is because when we're always multiplying. Let's go back to our material code here. We're always multiplying our direction by 50. So even if there's the slightest direction, it snaps to like an angle of 50. So that's why it's like really herky jerky. It's either like a degree, like an angle of 50, or pure nothing. So move intensity, let's hop back to our material code. We'll set this to 0. And then in our code, we are going to start affecting this move intensity node in the blueprint. So I'll set this to 0 here over in the details panel. I'm going to head back over to the blueprint. We're going to need to make some space, and we're going to need to pull out of our material reference and set a scalar parameter value this time. So let's copy and paste our matref node and pull out of it, and you'll look for set scalar parameter value. Okay, now we need to give this a parameter name. If we hop back to our material, our parameter is move intensity. So we'll take that, plop that right there. Okay, so this move intensity, where are we going to get this from? We're going to use the distance between the current and past location and we'll feed that into the intensity. So let's pull out of one of these vectors the past location or current. We'll pull out of there. Sorry, excuse me. We'll search distance and pull up the distance vector node. And then feed this into the material node we just made. Now let's run it again, see what it's looking like. It's more reactive now. Isn't that fun? Okay, so we got the movement down. We now need to go to our rotation. Let's hop back to our material and drag this out of the way. Let's disconnect everything from the world position offset for now. And we are going to, okay, so let's think. With the material, how do we like rotate the vertices? Isn't that kind of weird, right? Because in the end, what's happening is the bottom piece is spinning and then the top piece is delaying. How do we like rotate the verts? How do we gain control of that? So there's a node that we'll use called rotate about axis. Once you got that, feed it into the world position offset, and you'll get some lovely errors. Place down a vector 3 by holding 3 and clicking. Feed that into the top. Hold S and click to place down a scalar parameter value. Call it rotation amount. You'll need 2 more nodes. You'll need an object position node and the world position node again. Object position, we'll pull that out and feed it into the pivot point. Pivot point, as it sounds, this is the location that we want all the verts to be rotating around. And then so we'll pull out the world position node and feed it into the last part. Alrighty, so we are rotating on the yaw. When our guy is spinning around, he's going to be rotating on the yaw. And the axis that we rotate through, if we're spinning like this, we need a vector up. And so to do that, we're going to feed a 1 into the B channel of this vector 3 here. This is equivalent to an up vector. And now, if you guys want to try around some values in the rotation amount, keep it between 0 and 1. But you can see now we have our mesh rotating. And it's as simple as that. For funsies, if you add a time node and feed that into the rotation angle, you get a little spinning camera. So isn't this interesting? If you want like a floating power up that spins around, you don't necessarily need to do it with blueprint code. You could do this all with materials. Kind of interesting to think about it. So let's bring rotation amount back to 0. Let's comment this code and call it rotation instructions. And so what would happen next, remember going back to that Photoshop file I was looking at, we have instructions and then we have our gradient. What if we multiply them together? What would we be seeing? So let's go preview how that would look. Let's put a multiply node down. Let's feed our gradient out of the power node. Let's feed that into the top of the multiply, and then our instructions into the bottom of it. And then feed that into the world position off. Now, if I change rotation amount again to something like 0.2, Now we're starting to twist. Very cool. Return rotation amount to 0. And then what are we doing next? Go back to the blueprint. Let's start there. We'll need to do something very, very, very similar to what we did with the move location and the drag. So we'll need a new variable for past rotation. We'll need to get access to the material and start affecting the rotation amount. And we'll need to like set the past rotation after each time we're doing that instruction. So let's start by adding that variable, past rotation, and then change its type to be a rotator. Pull out past rotation, make it a set node, pull out our mesh, get the world rotation, and set it to be the past rotation. Let's go over here to the mat ref. Let's go over here to change the node, to copy and paste the node that's changing the move intensity. Let's copy and paste it and change it to rotation amount. All right, so we need to, again, do something very similar with that we did with the location. We're going to pull out the past and current rotation values and subtract the z from each of them because the z value in a rotator is the yaw. So we're going to pull out past rotation. We're going to copy and paste the mesh world rotation from over here. We're going to right-click and split both of these. And then we're going to subtract the z's from one another. Okay, so let's run this code and see what's going on with it. Let's run simulation mode, and then let's go to the rotate and start spinning it. And you'll notice it's freaking out. And this is not what we want. Let's figure out what's going on here exactly. Let's print this value.
Is that not between 1 and 0 and 1?
That's exactly what's going on. We're getting numbers much higher than 0 and 1.
That's right. You got to divide that by 180.
Yeah, up in the corner, we're getting like numbers up to like 20 and stuff like that. So this is spinning multiple times over every single time, every single frame. Not what we want. So you could divide it by 180. Let's actually try that. That might be a good number. Because I started with like dividing by 360, then I was like, that could be adjusted. Brought it down to 100, and I was like, that's cool. So this is one of those cases where you just kind of want to fine tune it to whatever preference you want. $180 is a really good number, actually. And I mean, that's pretty much it. You got the movement dragging behind, and you got the rotation dragging behind. I do need to hop back to the material really quick because I disconnected the movement instructions. And you all probably did too if you were following. So the big question, how do we possibly combine like this set of like rotation instructions with like the movement set of instructions? There's this crazy node called the add node. And so you'll add those two together and then feed it into the output or feed it into the input. And so now if we were to move this guy around, he wiggles. If we were to spin him around, he wiggles. So if you were to set up controls to move this guy around in some way, you brought a little camera guy to life. We could stop here. There's one extra step I could do that adds more control to how much it lags behind. Sweet. Okay, so we'll need 2 new variables. We're going to call them current location and current rotation. Sorry, call them target location and target rotation. I lied to you right to your faces.
And we fell for it.
I'm so sorry. Okay, and we are going to use a lerp node to slowly, how do I describe this? I want to ease to our target value. I don't want to go based off of where the thing is currently. The thing can move around and that's fine, but I want like this imaginary value that lags behind it. That's always easing to like where it really is. So what we'll do before this movement code here, these 2 material nodes, we'll add a set target location node, make some room for this, and add a lerp vector node. You're going to feed that into the target location. And now you'll need your past location and target location as the inputs here. And then set this to 0.5 for now. The alpha value of the lerp, I mean. So nothing should have changed yet because we're not using target location, I just remembered. Down here, we're going to delete where it says get world location. And in its place, you'll drag out the get target location node. Actually, change the alpha from 0.5 to 0.9. The closer it is to 1, the more exaggerated the delay will be. And then run it and see what happens when you move it around.
It's going in the opposite direction.
Yes, just remove that negate vector node.
This is the start of like jiggle physics. There.
Hey man, it's a slippery slope in this industry. Okay, so 0.9 is really exaggerated. We could fine tune this. I think 0.7 was pretty good. But yeah, just to show you kind of like the control you gain with this. Fun. And now we'll do a similar thing with the rotation. So we're going to need a lerp rotator node. What we're going to do is feed in the past rotation and the target rotation as the inputs, and then set that as the target rotation variable. So let me get over here and do all that. Lerp rotator. We're going to send past rotation, target rotation into our inputs. Let's set the alpha to 0.9 again, just to see a pretty exaggerated version of it. And then we'll toggle on the shortest path. And this will do a similar thing where it flips the result. So we'll need to swap this subtract node, like the inputs, I mean.
And should we remove that and set that to be target rotation now?
We should. Yes, good point. And we should do a check-in on how we're doing again.
Check, check.
Let me see. I think it might be too much. Oh, hell yeah.
Like jelly.
Jelly.
Jello.
That's kind of fun, actually. So yeah, we could bring this down again. 0.7 might be a good ballpark. This is all your fine tuning, your own choice at this point. Yeah. I'm gonna jump to my like final version of this so you guys can see like the amount of extra layers and controls that I've added to it. So here's like my full material for the original version that I had. But yeah, like some small like details worth mentioning, or just the way that I did it. Our gradient like section of our code, there's one time, we have it one time, and we're using that same gradient curve to affect both how much the top spins and how much the top bends and stuff like that. I've kind of given the bend, the spin, their own version of that gradient that's just slightly different to fine tune it a bit more. I think I added some stuff where if I'm going in this direction, I'm squashing it like this as well, just so it extra like bends and stuff like that. There's some interesting stuff here. And I love shader code. I also made it so it works with other meshes. This guy's really, whoa, really droopy. Okay, that's officially the ending. If there's any questions, fire away. I'll do my best to answer. Yeah.